All right, so we're going to take this same concept and we're going to start throwing these to the bottom, and we did some of this yesterday, to the bottom of a fraction. So what if I have something like this? Y to the 5/6 power over y to the 1/6 power. Okay, look at that real close. Tell me if you have any ideas of how to do this. There's a shortcut. Here's my hint.
You subtract.
That's it. Okay, if the base numbers are the same, what do you do with the exponents when you're dividing? You just subtract them. What is 5/6 minus 1/6?
4/6.
4/6. So I have a y to the 4/6 power, but understand that has to be reduced if you can reduce it. So 4/6, I can divide the top and the bottom by 2. So my final answer is that.
Oh,
Okay? So don't make, now you can go the long way of doing this. Okay? The long way of doing it would be, oh, I've got a 6 root on the bottom, so I have to get rid of that root, so I have to take it to the top. I'm not going to show you the long way on this one because I'm afraid it's going to mess up your head. Okay? Do we understand the shortcut there? Okay. Let's do another one because we're going to hit one where we can't do it with shortcut. What about, let's see. If I have something like this, x squared over y to the 1/2 power times y over x to the 1/3 power. Any ideas?
You cross them.
You know, you could do that, and this is what, you know, this is, Nathan's going to put that with that and put this with this. Okay, so I can rearrange this because there's no order to multiplication, and I can look at it like this, right? Now what do I do?
Subtract.
Then I subtract my exponents, okay, because these two things match. Then I have 2 minus 1/3. What is 2 minus 1/3? Very good question, right? Okay, so think about it. 2 minus 1/3, you can do it on the calculator. The common denominator is going to give me, this is going to be 6 over 3 minus 1/3. So I have 5/3, right? Would you not, is that all right? Okay, so I have x to the 5/3 power. But again, you can do it on your calculator, just make sure you put that in parentheses when you do it, okay? So I have x to the 5/3. Now what am I doing here? What's he understood here?
Well, you just put it there.
I know, so now what's my answer?
1/2.
1/2. Y to the 1/2 power. Now I want to be able to put these all underneath the root, okay? How can I, now they don't have the same base number, but I can figure out the root that they can all go under by finding a common denominator. So what's my common denominator between those two? 6. So I can rewrite it with a 6 on the bottom. So that one's going to be 10/6. This one's going to be 3/6. Now I can write it as the 6th root of x to the 10th power and y to the 3rd power, right? Am I done? Why not?
Because you can take some of it out from underneath.
This power is bigger than my index. So now I go 6 times what equals 10. So it would be x to the 1st, okay, because 6 times 1. How many x's do I have left over? 4. So then I have the 6th root of x to the 4th power, y to the 3rd. Okay? Now, if I wanted to do it up here, that's when I take that and make it a mixed numeral. And remember, I can't state it as a mixed numeral, so I actually could say that's gonna be the same as 1 2/3, because I'm gonna reduce 4/6 down. Okay, so therefore I have x times x to the 2/3 times y to, actually I need to leave it as 4/6. And here's why. Because those two things matching would then make it the same as this. Okay? And I actually probably would accept that answer, okay? Because that tells you got most of it done. Okay, I'm gonna give you one to do. Okay, so see what you can do with this one. Now notice you have a radical on the bottom. So you can't keep that radical on the bottom, you gotta get rid of it. If you're stuck, if you get stuck, if you get in one like this and you go, I don't remember how to do it, change this to roots. And then I think it'll fall into place, because we've already done those. So in other words, this can be rewritten as 24 over the 3rd root of 6 squared. Okay, now you know you gotta get rid of that root on the bottom. These were the ones like I separated the board yesterday into the 2 different ways to do it.
I have a question.
Uh-huh.
I'm not quite sure.
Okay, you're gonna, no, perfect, that's perfect, okay?
Like,
Except, okay, yeah, no, that's right, and then you can reduce that, yes, yeah.
Sorry, I wanna do it like that, but I forget.
Okay, I need to be able to get rid of that root,
Mhm.
so I need that number to match that number, which means I have to multiply it, top and bottom, by that. Because then I would have 3 of them. There's 2 here, and there's this one here. Okay, so on the top, you have that. On the bottom, you have that. Okay, these 2 things reduce down to 4 over 1. So my final answer is that. Okay, does that make sense? Yes, no, maybe?
No,
No, okay. Okay, you wanna do it this way? Oh, that's right, you're good, you're good. Okay, so on the top, I have this, okay? On the bottom, I just have that, right? Cause it cancels out. Now reduce that. What is that? Right? Okay, you were there. Yeah, you were there. Okay, the only thing that you're, oh, no, wait a minute. Okay, I need this to match this, right? So that 3 has to match that thing. So I only need one of these. Because that's gonna give me 3 total. 2 here and 1 here.
Oh.
Okay, so then I have, on the bottom, I have just 6. Because the 3, because that's gonna be the cube root of 6 cubed. Okay, then I can reduce that down. So that's my final answer. Remember that? Okay.
Yeah.
All right, look up here for a minute. 2 different ways to do this problem. Okay? Left-hand side, and I don't know if any of you did it this way, but you can. I need 3 over 3 on the bottom to get rid of the roots, okay? So what I would need to do is I would need to multiply it by 6 to the 1/3 power. 6 to the 1/3 power, okay? Y'all with me? Okay, so that's gonna leave me 24 times 6 to the 1/3 power. Then I have 6 to the 3/3 power, or just 6. Those two reduce, which is going to leave me 4 times 6 to the 1/3 power. Most of you didn't do it this way. Most of you converted it like this. I need this number and that number to match to be able to get rid of my root, which means I need one more 6. So I'm going to multiply it by the cube root of 6, top and bottom. So on the top I have 24 times the cube root of 6 over, when I multiply that together, it's the cube root of 6 cubed, right? Which is just 6. These two reduce down, so 24 over 6 reduces to 4 over 1. So my final answer is that. This and that are the same thing. Okay, did anybody do it that way? You did do it that way, okay. I think that's the easiest way. The only reason why most of you are doing it this way is because we've already done it that way, okay? You already are familiar with that. All right, here's another one. See what you can do with this. Same concept. I'm going to separate the board. I'm going to do it both ways, but don't look up here until you actually have your answer down. This is another problem, Bella, and I'm working this out, so don't look at my answers until after you, and this is very similar to the one you just did, okay? Got it now. It's weird. It's very different.
Seems kind of easy to do.
What?
Seems kind of easy to do.
Now, okay, yesterday when y'all first saw it, it seemed really not easy, but it is relatively easy and a lot compared to learning all the rest of that chapter that we did. I think the second half of the chapter is easier. Okay. Because now some of that stuff is just instinct of how to do it. I'm gonna have you do one more. Did everybody get this?
Mm-hmm.
Okay, I'm gonna have you do one more and then we're gonna go on to other stuff, okay?
did 3 on my side, like 1 over.
I thought it was yeah.
Oh, this should have been a 2. Should be 2. I just copied it wrong. Thank you.
I was thinking right now when I did though.
Make sense? Okay. Alright, continuing on in the same section. Everything that we've had so far on the bottom has been a monomial, but sometimes they put a binomial on the bottom, like this one. Okay, now, that, if I wrote it the different way, what is this equal to? Okay, and I think, something I didn't think got it. Oh, no, they don't have it up in the power, that makes it easier. They've got it like that. Sorry, I made it more complicated than what it had to be. Okay, that on the bottom is the same as what, if I put it with radicals?
A squared.
Square root of a minus 1, right? Now remember, you cannot have a square root on the bottom. How do I get rid of something like that? Going back to the first half of this chapter, what do I multiply it by? If it's a binomial. Do you remember that term? The conjugate?
The opposite.
Right, the conjugate of it, the opposite of it. Now, I can do it, oh, that's okay. Well, we kind of adjusted,
Okay.
we adjusted.
I figured you might have another book, but
Yes,
you didn't message me
yeah.
back, so I brought
No,
it.
we adjusted, thank you.
You're welcome.
So again, you can do this 2 different ways. You can do it with the powers, or you can change it to the roots like you're used to doing. Okay, so if I change it, we'll do it the way that we were used to doing it first. Okay, so that's going to be the square root of a plus 1. This is going to be the square root of a minus 1. What am I going to do? I'm going to multiply it by the square root of a minus or plus 1, square root of a plus 1. Okay, the opposite of what I have here. Y'all remember this? Okay, now you can groan because that's what you're going to feel like doing. You've got to do FOIL.
Dang it.
You have to do FOIL. Now, I might on this one, on this particular one, if you put the square root of a plus 1 squared on the top, I would just give you, okay, that was smart thinking, okay? Now, you can do the FOIL out on the top, but do you see how they match? So they're the same thing, okay? So if you did it like that, you would be okay. I would have to give you credit for it. What do I do on the bottom?
Florida.
Florida, okay? What's the square root of a times the square root of a? A. What is negative 1 times 1? Negative 1 times 1?
7.
Is that stretching your brain a little bit? Oh shoot, that's why I set my